Welcome back to Summarize Science, where we break down the latest research into simple terms. Have you ever wondered how you could get a live video feed from a submarine to a drone flying high above the ocean? It's an incredibly difficult problem because radio waves don't travel well through water, and sound waves are far too slow for high-quality video. A promising solution is to use light, essentially a laser beam, for high-speed data transfer. But there's a major catch: the constantly moving, wavy surface of the ocean. Trying to keep a laser perfectly aligned through this chaotic interface is like trying to hit a tiny, moving target while looking through a wobbly piece of glass. A new paper proposes a groundbreaking solution to this, using a sophisticated AI to act as a superpowered marksman. The core idea is to equip both the underwater and aerial vehicle with a camera system that watches a beacon light from the other end. This is where the AI brain, detailed here, comes into play. It takes in a sequence of images, essentially a video feed of the beacon, to learn the pattern of the waves. The researchers built a special AI model combining several powerful techniques. First, it uses a component that's excellent at understanding the spatial information in each image, just like our own vision. Then, it feeds that information into another part that specializes in understanding sequences over time, allowing it to predict where the wave will be next. It even includes a clever attention mechanism, which helps the AI focus only on the most critical visual cues to make its predictions even more accurate. So, the big question is, does it actually work? The researchers ran extensive simulations to test their system against other methods. As you can see in this graph, the signal strength received using their AI, the top red line, is consistently stronger and much more stable. The other methods result in a spiky, unreliable signal, meaning the connection would constantly drop out. This next chart is even more telling, showing the actual tracking path. Their AI-guided system, in red, follows the true path of the target almost perfectly. In contrast, other methods, like the blue and green ones, are all over the place and clearly struggle to keep up. The system is also incredibly robust against noise. Even when the simulation added visual noise to mimic bright sunlight, their AI maintained a far more accurate lock on the target than its counterparts. So let's recap the key breakthrough here. This research presents an AI system that can intelligently predict the distortion from ocean waves in real time. It uses this prediction to perfectly aim a communication laser, creating a stable, high-speed link between the air and the sea. The implications for the future are huge. This could enable real-time, high-definition video from deep-sea exploration drones. It could also allow fleets of aerial and underwater drones to work together seamlessly on missions like search and rescue or environmental monitoring. It's a massive step towards bridging the communication gap between the world above the waves and the vast, unexplored world below. Thanks for watching Summarize Science.